Okay, appreciate it. Thank you for giving the opportunity. And sorry for my voice, I'm catching cold or something, I'm not sure what's going on. So my background is usually involved in some sort of startups that have an open source code base that has got some community traction, and either in the web infrastructure space with JBoss and Red Hat, and then in telecom software infrastructure space with Telestacks. In the last couple of years, I've had kind of the time and opportunity to dig into smart connected devices as a curiosity, and it was something related to trying to figure out a way to keep an eye on my dad, who's aging and he's remote, and I know he's fallen a couple of times and doesn't tell anybody, so I'm trying to find a way to be alerted if that happens again, so we can react on time. Turned out that the available kind of common smart cameras starting to get some functionality, but they're kind of going one step forward, two steps backwards, and either they're closing the API or the way to access them, or because of some sort of breaches or legislature, they're pulling back on their AI capabilities. So the question is, like, can we do this kind of more collaboratively as an open source community, and allow innovation to happen, but in a way that's transparent and safe. So just to move into the presentation, but before that, of course, thanks to sponsors and the organizers, everybody who made this happen. It's a good event. I remember right before COVID, the presentation in Austin, the venue was just humongous, just so many people, felt like 1,000 people or more. That's really cool. Hopefully we'll be back to that next year. So with the current web tech, I guess we've pushed it as hard as we could, but the kind of the common pattern is, collect as much data from the users as possible, and then gather it somewhere, ask them for permission to be compliant, and then try to make sense of it, sell it, use it to improve products. For the most part, I think these are with well-intended reasons, but as we've realized by now, there are many cases where centralizing too much power and too much data leads to pretty unexpected and unpleasant side effects. And since I'm mostly working on smart home devices, security cameras, lately, the two examples that I'll point out that most of you, I'm sure, have seen already is, hackers, threat strangers accessing a Ring or Nest cameras and seeing and being able to talk to kids at homes without the parents' knowledge. That's on the consumer side, but then on the enterprise side, vendors are, camera vendors are getting hacked and at scale. So hospitals, prisons, factories are being exposed to this type of leaks and surveillance. That's not really, I'm sure, the intention of the customer who bought these devices. A quick perspective, as of this year, the statistics are there are 35 billion IoT devices around the world. The average home has 50 connected smart devices. And we don't really think of this thing as much in terms of their exposure to access to our privacy as much as we would think as a laptop or a mobile device, because we're normally, when you work on a laptop or phone or a tablet, you kind of are already conditioned and trained to update this thing, right? Get it up to the latest version and make sure that your behavior does not enable phishing attacks and you have the proper antivirus installed. But when it comes to cameras and devices, baby monitors, things like that, the smart voice controls, I don't think we have yet that type of discipline to think, are these things updated? Are they running the intended firmware that's secure, or did somebody hack them months ago and they're running the firmware that they want, remotely controlling it and using this thing in a way that I have no idea is definitely not intended, but I don't even know what they're using it for right now, which is happening. A couple of months ago, again, there was a massive breach of Ubiquiti networks. So hundreds of thousands of cameras and Wi-Fi routers, antennas got hacked. It was, in that case, there was a whistleblower who came out and told the story of there was a transition of the sysadmin, not sysadmin, but one of the administrators with access to all the security keys for all the devices. They transitioned out of the company, handed over in a way that wasn't very secure, and somehow their last password access, the application that keeps all the Amazon S3 keys and things like that, are in one place in that one app, and somehow that got leaked, and effectively hackers were able to control, upload whatever they want to all these devices around the world. That was a ransomware. Supposedly, that's the official story, for 50 Bitcoin to pay or to regain control, but who knows if it was a nation state or something else. But the whole point is that, again, it back to the centralized kind of GODI access, having to trust a vendor to keep all your data safe, all our data safe, right? So that's not quite working out, and legislators are starting to catch up with that. There is a new version of GDPR from this year that significantly restricts use of intelligence on these devices when they're connected, and it mostly targets again vendors that collect data and for commercial reasons. The intention is not so much to restrict innovation at the edge, restrict consumers and end users having access to innovation, but it's to protect them. But the effect is kind of not where it needs to be in terms of implementation. So the reaction from vendors that have this type of centralized data gathering is to just turn off all this cool technology. So, the new meta game, pun intended here, is let's just not use AI. Because we have the data, but we're not going to do much with it. We're going to do less with it. And I don't think that makes much sense when you think about building new products that actually provide more value to the end user. I'm not sure if the right direction is let's cut features that make sense. Maybe the better way to think about it is let's build products that offer these features but don't harm users. They help. So the big trends that are that I'm excited about and I think have potential are the new privacy-preserving, decentralized, trustless building blocks for the new internet, so the kind of the Web3 direction, where you can still build apps that are user-friendly, that have a ton of value, but don't have the privacy and the trust-based issues of the existing Web2 cloud-based apps. And for where it makes sense, of course, use the existing technology, but when there's sensitive information, use it in a way that's meaningful and safe, and does not go back to doing things the old way. When you can actually apply a little bit more on modern technology and solve the issue. So I think the analogy is like with maybe Web 1, I guess, where most websites were over HTTP. And even though HTTPS as a technology, public-private keys were from the 60s and 70s as technology, it just took still good 10, 15 years, if not more, to where it's the norm. We can't even access the website now without HTTPS. So it's just the right thing to do. Right? The performance was worked out, and the implementations were worked out. So it makes no sense anymore to be passing back and forth over who knows how many hubs clear text data when you can just secure it end to end. So the next natural evolution is to take that end-to-end security and encryption, not just between clients and web services, but between clients and clients, as well as clients and devices. Those 35 billion devices that are out there and are currently centrally controlled for the most part, and any breach in that central control organization effectively can cause a lot of damage. So why not take this end-to-end encryption one step further and enable clients to, mobile apps or web apps, progressive web apps, the next generation, to directly communicate with these devices and let the user control what they need to control as they normally would through an existing web service, but not going through that man-in-the-middle trusted data storage architecture. The other big building blocks are the Web3 authentication, where you don't have to trust, again, a vendor with all your data, and that they're, even though there's a password to get to their database, the database itself is completely open to the vendor. With Web3 authentication, there's no need for any party to have control, centralized control of any people's identity. It's effectively down to the to these Web3 wallets, crypto wallets that everybody is responsible for safekeeping. And then another huge trend that I think is going to make a big impact on new generation products is the shift from AI that's trained on massive cloud compute resources by big tech or companies that can afford to run that much centralized AI training towards more on-device kept data with AI inferencing and even training running on devices where tasks of common interest can be collaboratively solved and attacked by cohorts of users who trust each other or who choose to work towards solving a task with their resources, so kind of pool resources together. That's kind of a federated learning direction. For my presentation, the focus is more on the first point, the peer-to-peer communication with end-to-end encryption. So I'll dive into that a bit deeper. So I'm not sure how many of you are familiar with the Webrtc standards. It's something that Google kicked off over 10 years ago, and over time it did get traction. So at the end of 2020, there was finally a Webrtc 1.0 stable support by all major browsers, which essentially allows browser-to-browser end-to-end secure communication for media and video, voice, and data. So that's the technology that a lot of the new gen video conferencing apps are using. One of the, as I mentioned, one of the features is that you can actually transfer data securely end-to-end. And it also runs in the user space. So in a browser, there is no need to have the admin rights on any particular device to install a VPN or dynamic DNS or some of these more traditional means to connect devices securely. The Webrtc stack runs in the user space, runs in a browser, and now there are a bunch of projects that implement it from scratch with implementations in Python and Go and on Node. So the stack can also run on a server or an IoT device, and that actually is kind of the lower layer that allows something that PureFetch implements, which is a HTTP-like API, like the HTML fetch API, which is how web apps see it on when you're writing a React or Vue app. You can use this fetch API to access web resources on a remote IoT device, and respectively on the server side, on the IoT device side, it's sufficient to run a regular REST API, some sort of open API network like Fast API or whatever is you like to use, plus proxy service that simply makes that API available to clients with permission to access that device. And what is not obvious, but is pretty cool with the Webrtc stack is that both the client and the server device or the IoT device can be and actually expected to be behind private firewall. So for example, I'm running this presentation from a hotel room and naturally behind their private network, but I am able to access the MBNX smart camera device in my home, which naturally is behind my home router's network. So neither of the endpoints has a public IP address, but they're able to connect, navigate, traverse the firewalls and connect end-to-end securely without running a VPN or any sort of admin access reconfiguration of the network stack because of Webrtc. I'll show a diagram to briefly illustrate the concept for people that are not familiar with it. So this is a kind of quick code snippet of what code looks like on the browser side and then on the server side respectively. So once the PureFetch class is instantiated with initialization options that essentially say we're going to be on whatever named P2P network, and one of the options is also to specify the signaling server, which is a central point that's ephemeral, does not have a database, does not store any data. It's simply a handshake mechanism that all the peers on the network can connect through. That signaling server does not see any of the data. It only sees and routes invitations for a handshake between peers, so they can find each other behind firewalls. But once that happens, then the peers proceed to do their own authentication to make sure that whoever just got in touch with them is who they claim they are. So the kind of signaling server's responsibility is just to make sure they have a way to find each other. If anybody has telecom background, it's got a telecom registrar, a SID registrar, HSS. But once that initialization takes place, the rest of it should look very familiar. It's like you would do a HTML, get from a host. That's how this works, and get a JSON and work with it. On the server side, again, the app only exposes a REST API, and that's all there is to it. Something to note here that may not be immediately obvious is that the host name is whatever is if you're running pure fetch proxy on the same device as this REST API runs, then this would be localhost, because it's from the perspective of the proxy. So once the client pure connects to the server pure, then the accessing web resources is relative to the host name of the proxy. And I mentioned earlier that the enabling technologies that are actually making this possible is the fact that Webrtc 1.0 is stable and supported by all browsers as of end of 2020. This would have been a lot harder before that. And progressive web apps is also helpful because it's making it not only it has this capability for peer-to-peer connectivity and encryption, but also it can run as a standalone app on mobile devices, even though it was built with the web technology stack. So this architecture diagram kind of illustrates what happens typically in a deployment where let's say that there is a case where we're deploying aging at home system where we want to be alerted instantly if a senior living independently at that house falls, which it's a common occurrence, and it leads to fatalities in a lot of cases if there is no reaction within an hour. It's called the golden hour to react. So we want that instant notification, and the ability for family member or nurse to access the feed or the events on a camera running at the house happens over Webrtc, over this pure fetch framework, where the purple lines are the data flow, and the dotted line is simply the handshake that allows users to be anywhere in the world, on any internet hotspot or connection, and still connect and access securely whatever data is being collected and monitored in a house running proxy and the AI inference with a camera, without again, without expecting any of this infrastructure in the house to have a public IP address. This is a different slice of the technology stack. The front end is regular progressive web apps, and we're using Vue, but it can be React, it can be any of the web tech. And then the communication to the device, let's say it's a Raspberry Pi with a camera, with a Pi camera. It doesn't go through a cloud service, it's direct. So there is the whole source code is open, and this is the GitHub link. There is also a video recording of a workshop, hands-on demo with some coding and Q&A at the Python Austin meetup a few weeks ago. And there's an article in the Webrtc Hacks blog about the in-depth details of how this is implemented. I mentioned earlier that peer-to-peer end-to-end encrypted communication is one of the building blocks. Federated learning is also this area where endpoints can work together, can pool resources together to solve AI problems and train AI models. This is just illustration. It started off a few years ago with Google showing how this works for predicting typing on the Android keyboard. And this graph shows this spike, the trend of research and frameworks and implementation on that front, federated learning. So it's pretty exciting. I think it's happening. Okay, that's the end of my slides. I'll be happy to answer any questions. And then after we're done here, we can go hang out in the yellow channel.